Okay, you should be able to see my slides. Is it true? Yes. So I will have the video on the left, just that I can have a feedback channel. And I'm ready, so let's go. Welcome, everybody. Today's topic is next generation CSS performance. One of my latest research that I did on a very cool thing, performance and CSS. So you can expect big impact with very little code changes, because CSS is mostly just small, tiny tweaks. First, let's start with the basics. If we look at the diagram, this is what happens in the browser if you want to center a div. No, just kidding. This is the RenderingNG. This is the rendering engine of the browser that is responsible for taking layout into dimensions, into pixels, composite them, animate them, and do all the heavy lifting that is done in the browser under the hood. And this is a lot, and it is a lot of complex stuff to understand. But it is essential for us to have a little bit clue, at least on that topic, because this is the work that we want to get rid of with our improvements. So we first need to get a little bit of an understanding what we need to get rid of. The new rendering engine, by the way, it was a year-long refactoring. It is called RenderingNG Next Generation. And I'm happy that they did the refactoring, because today's talk would not be possible without this year-long 10-year-long refactoring. What do we have on the table, on the menu? We have on the menu two different CSS properties, if this is the correct naming or typing. We have the contain property, and then we have the content visibility property. And both of those properties are here to reduce the work that is done in the browser render pipeline. This is these colored boxes in the middle, and the red crosses, red X's show you that we can skip or reduce work at particular pieces. Well, to understand how to apply that and where to reduce the work, we should understand the render pipeline itself. But first, let me give you a little teaser what is possible. For everyone that is not familiar with flame charts, this is a flame chart, a visualization of the work that is done in the browser. And the different colors map to the different steps in the browser render pipeline. And what we see here is a lot of purple and a lot of green. This is the stuff that I can change and affect without any JavaScript code, just CSS or the DOM structure. And of course, the content, the image, or whatever I show. And this is a before measurement. And after this talk, you will be able to turn this picture into the following picture. And if you're not familiar with flame charts, let me just tell you that this is called beautiful. You see no work at all. Red squiggles, always when you see red squiggles, not good. Whenever you see color, color means work. Here you see no color means nearly no work done. A really beautiful picture, and you will learn how to get there and how to understand what to do to get there. But there is this browser render pipeline, and is this very complicated thing that nobody really can explain easily. I mean, I will do hopefully a good job, but even this is not efficient enough to understand it fully. I guess you have to dig a little bit and experiment. And I'm here today to help you with this digging in, with this understanding, with this experimenting. My name is Michael Hladky. We can stick with Michael because Hladky is very hard to read, write, spell, pronounce. You can add more if you like. Yeah, and I hopefully can help you to solve all that problems. So the first thing that was like most important for me to even do the research is to get a solid understanding of the browser render pipeline. And I had a solid understanding before, but to do this really exact measures that I want to show you today, I really had to understand it clearly. And this is like a rough information for you to get a context on with what information I had to deal. what we see is user interaction, and this small snippet here, this small curly braces, this is code, JavaScript code in yellow. And then we have layouting, dimensional work in purple, and paint work in green. And I want to explain to you that this chain of processes is connected together, and I also want to elaborate why they're here and what is their scope of work. And the first thing that starts mostly everything in the browser is scripts. And I not particular now mean just the JavaScript that you write. It could be an event listener. And this event listener could be added to your DOM structure over a hover style with only CSS. So this is also JavaScript because this is a listener that gets active when you hover and then applies a different style. This is the yellow part. Then, of course, you have DOM and styles, and you load that and you start to render the page. And one of the first things the browser needs to do is, after he's done with fetching all the HTML and all the JavaScript and all the styles and all the whatever, he starts to identify like which element in the page, which representation in the DOM structure in the body is mapped to which style. And then I have this button, and if I hover over this specific button, the color is green or red or whatever. So I just know with this step where to apply what. Nothing visible yet. The next step in this process is to figure out where to place something and how much size it takes in our two-dimensional space, the dimensions of our nodes. And if you want to be really specific, and we see that in this talk, you not only have 2 dimensions, you have a virtual third dimension, which is the set index. And I guess all of us know that you can play with that around and really like flip which is overlaying another area. So this is layouting. If you interact, if you hover over something, you need a hit test because you want to know if the mouse pixel cursor pointer is really over that button or not. So you need to like somehow figure out where this element is. You have paint, and paint is basically, you know where it is, you know how big it is, and now you want to turn that information, that invisible information, into pixels, and then you want to color the pixels. And this is the paint process. And as you can have not only one paper that you want to paint, but multiple different layers in your page, there is a last step, the composite step, that composes all those different pixel images together into one single one, and then bam, the pixels update in the screen, and you see whatever you want to see. Beautiful information, or a video, or I don't know. So this is more or less the process that we want to dig through. And what we want to do is we want to improve the performance in that process. And we can reduce 2 colors with CSS only, the purple and the green color. So to give us some more guidelines and concepts, I want to introduce you to 3 different things: the border box, visible boundaries, and the screen's viewport. The border box is basically a box that tells you the dimensional values of a DOM node, of a node in the browser. It tells you how big it is, where it is positioned, which set index, all that stuff. Visible boundaries is basically a frame that tells us what will be displayed, because you can have overflow, and the frame can tell you how to treat overflow. In this picture, as you can see, the overflow is ignored, and you only color the inner thing. And the third concept that I want to quickly scratch is the viewport, and you can have all your structures in the viewport or outside of the viewport. Okay. With these concepts, I want to demonstrate quickly our testing environment. To do this, I bootstrap my testing application, and I quickly want to show you how I came to that numbers. This is my testing area. It is a very flat DOM structure, so that I don't have very much impact from other stuff. And here I can add DOM nodes. And if I hover over this demo DOM node, you see that I have this menu and this menu, like something, right? It's some demo content. And here I can apply the techniques that I talk about. And for example, if I apply one technique on this stuff, you see that things change. This is how I visualize the impact. But what I can also do if I remove everything, I can also insert demo content that is not really looking a lot, but just here to demonstrate how work is done. And here I have triggers. Here I can trigger layouting work. And here I can trigger paint work. And if I did my job correctly, in these flame charts, you should see two different things. First, the layouting work should show a lot of these purple colors, and the paint work should show a lot of those green colors. I realize I have it on the wrong frame. Let me do that measurement again. Maybe it's now working. Yeah. So yes, now we see two different things, right? A lot of purple here and a lot of green here. This means basically my triggers produce only work in the browser that is purple, and my trigger here, the green one, triggers only work that is green in the browser. So I can separate work that is done in the browser, and with this area here down, I can lay out how heavy the work is in terms of layout of purple or of green. So I can also insert green work like this. And if I would hover over something, you would see way more paint work than before. With this small introduction on my environment, I want to go back, and I hope that the presentation jumps in again. Yes, here we go. So here we have our first CSS property with all that knowledge that we can take and try to use it, because so much theory needs a little bit of practical examples, right? So the contain property has three interesting things: layout, paint, and size. And from the information from before, you can already link layout with purple and paint with green. Size is not a good demo case for today, but maybe in a follow-up research that I will ship. In this presentation, I have a lot of good measures for the first two. Let's start with the browser support. Everything green, latest, and also all the browsers. This is very nice and good for us to know, because it means this technique is solid and very reliable. We can really use it nearly everywhere. So contain has three interesting properties: layout, paint, and size. And for layout, I will use a dashed line, which is basically always the border box. And for contain, I will use a dotted line, which is always the visible boundary. And for contain size, I will have this double border with these dimensions on the outside. And now I want to start and have a really detailed look on all those three properties. They contain layout property. Let's start with performance. So what performance impact can we assume if we apply the contain layout property to a list of elements? Here we have our elements in the middle, these light gray boxes, and then we have our property with the red dashed lines put it on that list. If we do that, we can shield outside work, and this was my button that was triggering work somewhere in another area in the browser, and I could like protect my DOM elements from this work so that I don't re-evaluate this part of the DOM again and have the layouting, paint, and composite work there. The second thing that it does is, if I change stuff only inside of that list, I can also isolate the changes and maintain that within this list and not outside. And this is really cool. If you look down here, the second circle, the layouting circle, is white, which means we can reduce the work in the browser render pipeline at this step. But everything comes with a price, and we have to pay the price in our design, let's say, options. And the first thing is the position will be handled as it is positioned, like absolute in that stuff. It will remain, it will receive its own stacking context. And this will also mean that it changes a lot of where this element is visible and which element is overlapping or underlapping it. And to demonstrate this, I want to switch into our demo environment, and I want to remove all that elements and insert some demo content. And if I do that, you see now the item is visible. And if I click the button to children, I apply contain layout to all of that element. So every element in my CSS has now contain layout set, like you see here. And if I start to hover now over those boxes, you see that there is this weird overlap, right? And this is the reason, because the set index of every box is increasing because they now maintain their own set index. If I would remove contain layout, this will jump back and the stuff is working again. So this is a constraint that we really need to understand when we apply that thing. Let me remove all of that and let me insert my layouting content that should cause a lot of purple color. And I will start my recording, and then I will trigger that work, and then I will click this layout styling, and I want to apply that style to that container, and then I should see an impact in the work that is done. So let me do the measurement now. I trigger layouting work, and then I trigger the button, I apply the styles, and I trigger layouting work again, and I should see already heavy impact. While this is processing, it is done already. So we see that we have a lot of red triangles here at the top, and nearly every task has this red box at the top. This means a lot of work is done, and also a lot of this purple stuff. And if we zoom in into the left one, we see that the work is reduced a lot, and nearly none of these red squiggles is visible anymore. There is also another button where I can push all elements off screen, and I can do another measurement. What happens to the browser work if all elements are pushed off screen? But to save your time, I want to show you the real pure measurements. The one that I showed you now are a little bit dirty because there's green color included, which should not be the case. So the real measurement looks like this. I trigger work, I only cause purple work, and this is unoptimized. And then I wrap my container, and then the work reduces to 50s of it. And then I push all the elements off screen, and then the same effort. So no impact in off-screen elements, but for on-screen elements, drastical impact. Really, really incredible impact with one line of code of CSS. The second property is the contain paint property with the dotted lines. Let's jump to the performance impacts. We have a lot of them. Lovely. We have our container, and if we apply that to a list of elements, they are again contained and they are shielded from outside work. Also, my paint area reduced. I basically cut edges. I start to only paint stuff in my DOM element that is visible here. And I also don't paint elements that are outside of this DOM node, even if the DOM node is visible. And if the DOM node is outside of the viewport completely, of course, I don't render anything again. As you can see in the bottom, no green field color. So we have good improvements in that step of the browser render pipeline. But let's quickly measure it to see the impact. Let me remove all the items. Let me delete this. Let me insert some green work. Here is the green work. And now I click on none. I start my recording. I trigger paint work. Then I apply contain paint. It takes a little bit. And then I trigger paint work again. And we should see an impact. We should already see that there is a drastic drop. We can take the measures we have here, 3-4 seconds. If we would go here, we would see a lot less. And we have to really zoom in, and this is only 0.8. but I can do another measurement and I can trigger the work now and then push it off screen and trigger it again and also analyze the off-screen impact. And now I have even less work. Look at this on top improvement here. I have nearly nothing. I really have to search. Let me search for that. 0.2 milliseconds. I mean, this is maybe only the content that is visible here and nothing else. So this is a huge and drastic improvement. Again, a dirty measurement, a really, really nice measurement is done afterwards. Let me quickly show you the design implications. The design impact is now easier to understand than before, because now we somehow can really rely with content overflow. And this is easier to deal with in CSS, and also, I guess, very more well known than this stacking index problem. I can quickly demonstrate how it looks. I insert my demo content, move the content on screen. I have my menu, I apply the paint on the children, and even the last menu now is invisible because I cut out everything that flows over the yellow or the green dotted line. So those are our design implications that we need to consider. Okie doke. This is the beautiful lab measure, really, really nice. We have a 6 milliseconds unoptimized, 1 millisecond or nodes on screen optimized, and 0.15 milliseconds. Incredible cool improvement for off-screen nodes. And now think a little bit more practically. Do you have a lot of images? Yes, maybe apply contain paint, because they anyway need to maintain a width and height, and normally they don't have a lot of overlaps. So a good chance to have the first one-liner to drastically improve your, I don't know, web shop. Content size is the last one. I want to quickly show you the performance implications. I could not measure it that nice at the moment with my current demo set. I'm working on it and will update my slides. So if you see that talk in the future, maybe it is already included. I can just tell you it also reduces the layouting work a little bit, but it has a heavy design implication because the container collapses completely and you would really have to set your own size from outside, no matter what it is inside. There are shorthands. What is a shorthand? A shorthand is a combination of contain properties. For example, you can apply on one element contain layout and contain paint. And this is called a shorthand, a combination, and there are two shorthands, contain content and contain strict. Contain content basically adds all the benefits of layout paint, and contain strict a little bit more. There is a difference between all of them. I just spoke about layout and paint. This is an overview table I prepared for you. What is maybe the most important stuff for you to know is usage, easy, moderate, hard. I would really suggest to go with content because this is moderate to apply. You can somehow deal with the set index problem. You can somehow deal with the overflow invisible problem, but the other one is really hard to deal with. So this is my suggestion. You can go here. You have everything in a really nice overview. And I consider this property as done. And I want to skip, not skip, but stop this topic and go to the next and last property of today. I want to talk about content visibility. And to start with content visibility, we need a little bit more theory. We already know about the browser viewport. Let me give you some more words. There is the visual boundary, the red dashed line here that separates the visible part from the invisible part. And then we have nodes, and nodes could be above the fold. Those are called on-screen nodes, and nodes could be below the fold. Those are called off-screen nodes. And then there is a special type of node. This is none of both. This is called an obscured node, and you can see all the three node types here at the bottom. You can see an on-screen, an obscured, and an off-screen node. Very nice. With this information on how nodes are called, we can go to three performance concepts. One is the viewport observer, and the viewport, the size observer. The viewport itself could be applied to the visible pixel parts on the screen, or it could be also applied to the viewport of a specific element, just as a concept. With that concept, we can observe this viewport, and we can say a viewport observer is some mechanism underlying under the hood in the browser. Think about image lazy loading. The image is only fetched if it is in the viewport. There must be some logic that tells us when the element is in the viewport or outside of the viewport. This is one concept we need to know, keep in mind. And it's a lot about the visibility of this element. And the second concept that we need to keep in mind is the dimensional values of an element could also change. For example, if I resize the page, I need to do stuff, but not only resizing the page, but also resizing any specific element in the DOM could be observed. And with these techniques, we try to do stuff and we try to understand how content visibility is implemented and working. Water in my eye, sorry. Okay, I'm still alive. Content visibility, auto and hidden are the two things I want to talk about. Browser support is not really good. I mean, we have Chrome, latest versions of Chrome, Edge, Opera, all the same engine, but other browsers don't implement that. So this is the first thing that you should consider. And the second thing is the performance impact. And now I'm really excited to share this with you. So take in your head now the contain property, and the contain property had layout and paint optimizations. All those benefits apply automatically by default to contain visibility. So you have all the layout benefits, which reduce purple. You have all the paint benefits, which reduce paint green. This is like by default, and you can now consider if content visibility is not working, you can always have a fallback contain content, which is a good fallback to content visibility, cross-browser support, right? But the third and really exciting, game-changing improvement is that viewport nodes outside of the viewport are skipped completely from the browser render pipeline. What does it mean? It means that you don't consider them at all, not even for the very first step, recalculate styles, which is very expensive. You need to consider them. And as you can see at the very bottom, you skip any single step in the browser render pipeline for that nodes. Even DOM creation will be faster in the browser, and this is insane. I did a lot of audits, a lot of researches. We can, in our Q&A session, have a little demo where I can show you my performance audits and what impact in real-life projects you can land. But for now, just know that it is really insane. There are design implications. Everything is with a price, and the price that we pay here is the collapsing of the boxes. It is not that strict as it was with contain strict, but the boxes will collapse when they are outside of the viewport. Like if they are outside of the viewport, they are ignored, which means also their dimensions are ignored. That means they collapse to zero. So this causes, if you imagine it, a flickering in the scroll bar, and we have to fix that by applying a static height to them that will be active when they are outside of the viewport. The impact in performance, let me try to measure that live and then go back to the lab measures, because it is always cool to see how to click that demo. This demo is available for everyone, and I will fix the small bug that it has at the moment. Then you can really experiment with that. So let me insert a lot of layout work here, and let me also insert a lot of paint work all together, just like the full load of everything we can do. And then I will have a non-optimized version here, and I will start and trigger layouting work. This should cause heavy purple and paint. Then I trigger paint. This should only cause green work or as little purple as possible. And then I will apply the auto. I will trigger layout again and paint again. And this is the first measure that we do. And this should just prove that the same impact of contain is also applicable to content visibility. And as we can see, there are drastic differences in those two panels. The purple is way less, and here the green is also way less. No red squiggles visible, really heavy improvements already. Now let me do the second measurement, and this is like where the huge improvement comes in. I will trigger the same things again, just that we have a reference measurement. Paint. Yeah, and then I will push all of those elements off screen as far as I can. Let's see if we're really far. Okay, ooh, this is really far. Okay, let's go back. And then I trigger that work again. And here. And I should see nearly no work at all. Unfortunately, I scrolled in this measurement, so we should ignore the part here. But here we see work. Here another time work, but here nearly no work at all, a nearly empty browser. And this is really impressive to see. I can do a last measurement for the demo here. And this should also show very little work. Yeah, nearly nothing. So this is also off screen. Very nice. The lab measurements, way more accurate and way more reproducible. They ran multiple times. Shows same numbers, unoptimized 6 milliseconds paint, 11 milliseconds on screen is familiar to us, off screen not, because here, if you remember the impact for only contain, it was even, I guess, 7 times higher than now. And a layouting is nearly nothing. So this is incredible. And this improvement is quite a game changer, I would say, that is applicable with CSS only. Another overview. You have two properties. You have hidden and auto. Auto is the one that you see when it is visible. It just takes the size as it has. And visible, hidden is when it is outside of the viewport. And you can deal with this maintaining of the size with the contain intrinsic size property. There you add the static value in pixel. Then you can fix the CSS layout. The scroll bar chunk. And that's it for the theory, for the practice. And now I quickly show you some results that we can discuss later on. And I have way more exciting performance audits that I can share. They are also open sourced. But let's give our record, the audience that just watches the video, the chance to see the impact. This is a lab staged measurement of a lot of cards and images and normal content, but demo content, like always the same thing. Different images and so on. It takes a lot of time to render it. Off screen, we have some flickering because images are lazy loading and there is some noise. If we apply our knowledge, we can reduce that drastically. No on-screen, no paint, nothing. Also runtime, not only bootstrap time. So this is our runtime work, and we apply if we apply all the knowledge, we get down to nearly nothing, including the off-screen nodes, of course. So this was the lab content. I also show here 2 out of 4 real audits. One is a project that was already focusing on performance. It's the Angular Movies project, very performance optimized. Even here, if this project was done by knowledgeable people, I can reduce the time from 160 milliseconds to 25, from 30 paint to 7. A very nice improvement overall still. There is a huge project that my company consults, and we helped them to drop a lot of total blocking time. Here we see we even reduced to 0 in some cases, only with CSS and some considerations of the DOM structure. And that's it. Yeah, that's really it. I will share more in the discussion later on. For now, I have to say thanks for your time. If you're interested, I, of course, also offer performance audits. I can support your company with a lot of things. I can help you to fix your problems really quickly. Just let me know if you're interested. And I hand over the mic to Christian again and stop this presentation here.